Okay, determine whether each function is an example of exponential growth or decay, then find the y-intercept. I do not need you finding the y-intercept. It's easy to do, and I'll explain it, but I don't need you to do it. Y equals 100 times 0.25 to the x power. So, it's an exponent function, they all are. It's a growth or decay. Now, one way you can use to find it is to set up an input-output table with 0, 1, 2. You don't need the negatives because you don't have to graph. So if I take 100 times 0.25 to the 0 power, it's going to be 100 because this to the 0 power is 1, and then 100 times 1 is 100. That's the y-intercept there. The y-intercept occurs when the x is at 0. So 100 would be your y-intercept. I don't need you to put that there. Now I want a 1 power, so it's essentially 100 times 0.25, which is 25. Now I want a 2 power. That's 6.25. So that's decay. Okay. Okay, number 2, y equals 7/8 times 18 to the x power. 0, 1, 2. Okay. That's going to be 7/8 if you do the first one. Then you're going to get 15 3/4. Then I think you're going to get 283 1/2. Let's see if I'm right on that. Yep. So that's obviously growth. Now you can tell by looking at the function whether it's growth or decay, which is what I'm going to do on numbers 3 and 4. The coefficient 0.2, the base on the exponent is 5/3. Since the base, 5/3, is bigger than 1 whole, that's going to be a growth. Okay, I know that without making the table. Just like that. That 0.25 is less than 1 whole, decay. 18 is bigger than 1 whole, growth. Y equals 0.7 times 1/5 to the x power. Okay, 1/5 is less than 1. Less than 1 whole, so that's going to be a decay. FY, the y-intercepts would be 0.2 and 0.7 because you'd set the x to 0, but then it just becomes 1, and then so forth. Okay, graphing. Graph the function, identify the domain and range. So y equals 3 times 3 to the power of x plus 3 minus 6. You better get the power symbol, then you better parenthesize the power in its base, and then if the power's got an operation, you should block that, separate it, so then we deal with the parent function 3 to the x. Now I'm going to need an input-output table. Now is this growth or decay? That 3 is bigger than 1, so it would be growth. So I want to start with the positive inputs, work my way into the negatives, and use -10 to derive my asymptote. So 2, 1, 0, -1, -2, and then -10. And you're going to have to know your asymptote. Okay, so I'm just going to go with 3 to the x power. So if I put a 2 in, 3 to the second power is 9, and then the negative second would be 1/9. 3 to the 1's 3. 3 to the negative 1's 1/3. 3 to the 0 is 1, and if I take 3 to the -10, it's approximately 0. Now you have operations outside. Within the exponent, you have a plus 3. That does the opposite operational effect to the x, so it would be a -3. The reason why is because you'll see this here, if I take 2 and -3, 2 minus 3 is -1, -1 plus 3 turns it back into 2. Now, outside the base exponent, times 3 and -6, those do the same operational effect to the y, and that includes the asymptote, because it ain't going to stay 0 when we have to multiply the outputs by 3 and subtract 6. So 9 times 3 is 27, minus 6 is 21. 3 times 3 is 9, minus 6 is 3. 1 times 3 is 3, minus 6 is -3. 1/3 times 3 is 1, minus 6 is -5. 1 ABC, 9 times 3 minus 6 is -5 2/3. and then 0 times 3 minus 6 is negative 6. And that brings my asymptote then to negative 6. Okay. Also, whoops, I have just about forgot. You got a minus 3 from all your x's. Negative 1, negative 2, negative 3, negative 4, negative 5. And even though I'm not going to graph the negative 10, I'm still going to subtract 3 just to be consistent. So now I'm ready to graph. I'm going to go by 5s on the y-axis. 25. You got to set up your asymptote before you start graphing the points. So negative 6, since this goes by 5, negative 6 falls about right there. Just sketch a horizontal line across there, better than mine. And then 121, okay, negative 121. Negative 2, 3. Negative 3, negative 3. And then you go up extreme that way, and then this way you don't cross the asymptote, you just get infinitely closer to it. Don't cross it or it's wrong. You need an arrow on both ends because they both domain. There's no restrictions for the x. You can put anything in a power you want to, so that's all for the domain. Now the range, obviously, there's that restriction point of the negative 6. And you are only above that restriction point. So since you're above it, or you can tell by looking at your table, these y values are bigger than the negative 6. It's greater than. Not equal to, though. It will never be equal to it. Okay, 7-minute mark. Graph the function, identify the domain and range. If you have a log, here's what you're going to need to do. You're going to first need to switch the x and the y. Swap the x and the y. You're going to write an inverse function. Now when you do that, you're going to need a little table over here, so when you get your main table made, you flip the values back, okay? Now, you got to get the y by itself. Remember, you're doing an inverse function. So first thing, if y is in a logarithm, you're going to parenthesize the logarithm. You're going to get rid of that operation after the y. You're going to add 2 and add 2. So now we have x plus 2 equals log base 3 of y. Now, we're going to get rid of the logarithm from the y side. This is to get rid of it. That's your base. The 3 is. X plus 2 is the power, and then this leftover y is the product. And the product's going to be all by itself, so then the y goes here by itself. Then I put base 3, caret, and then x plus 2. Now I have this looking exactly how I want to set up the input-output table. Okay? Parenthesize the base and the power, separate it, and it's a growth. So we're making the same table we did in the previous problem. 2, 1, 0, negative 1, negative 2, negative 10, and then there's that asymptote that comes into effect. Y equals. Okay, so I raised 3 to these powers just like the last one. 3 to the 2 powers 9, so this would be 1/9. 3 to the first power is 3, 1/3. 3 to the 0 power is 1, and 3 to the negative 10th power is just approximates 0. Now, in the exponent, within the exponent, you got a plus 2. That does the opposite to the x, and you don't have any outside operations, so the y will stay. So a minus 2, that'll be 0, negative 1, negative 2, negative 3, negative 4, negative 12, okay? Because you're minusing 2 to all of those. Okay. Now the y stays, so the asymptote's actually going to be 0. But since you had to switch the x and the y, you have to now come over here and flip them back. 9, 0, 3, negative 1, 1, because in the actual function, the x and the y switch places, okay? I switch places so I'd be able to derive my original table. Now for the inverse, I go back, okay? 1/3 negative 3, 1/9, negative 4. Now the asymptote is still 0, but instead of y, it's x, okay? So now if it's x, it's a vertical asymptote. So on the x-axis, 0 is right here, so it's just right in the middle. Now we can go by 1, so 9 on x is all the way at the end, y 0. 1, 2, 3, down 1, and then 1, down 2. So what happens is now it gets extreme this way, and then here it just gets closer to the asymptote. Arrows on both ends, so now it like inverts it, reflects it on the axis. Now, this time it's the range that's all, and it's a domain where I put the x with 0. Now, I want you to look at your table. First off, if all points are to the right of that asymptote, it's greater than. Or you can look at your table and say, gee, all those x numbers I got, they look like they're bigger than 0. 1/9, 1/3, 1/3, 9, so it'd be greater than. Okay, write each equation in logarithm form. If you don't remember how to do that, I want you to compare these, okay? Log base, 9's your product, 2's your power. That's because 3 to the 2 power is 9, so look at that. So if I want to write this with a logarithm, okay, 3 is my base, 4 is my power, 81's the product. Now you're going to write the word log. Your base, 3, goes down here as a subscript, and the power 4 comes here, and then 81 right there. Okay, so you can look at that. Well, same thing on the next one. Base, power, product. So I write log down. The base 8 goes here. The negative 2 is over here by itself, then 1 over 64. That's all you do on those. Okay, next part's pretty easy too. Now you're evaluating what the logarithm equals. You're essentially figuring out 7 to the what power is 343. So you start with this, okay? You start multiplying base 7s till you hit a product of 343. That's 49, and right there that's 343. So how many factors of 7 do I have? 3. If it goes over 343, you have to do the COB, log over log, with this on bottom, this on top. But I think I can get through this side without doing that. So, 8, 64, 8 times 8 times 8 is 512. So how many factors is that? 1, 2, 3. Okay, log base 9 of 6,561 equals. So we got 6, 36, or sorry, 9. 9's a base, my bad. 9 times 9 is 81, times 9 is 729, so I'm not above the 6561 yet. Times 9 is 6,561. So how many factors of 9 was that? It was 4. Okay, log base 2 of 1 over 16 equals. So I want to do it from 2 to 16. So if to make it just 16, you can just make that an equal to a negative. Now you can just multiply 2. That's 4. 4 times 2 is 8, and that's 16. Since it's 1 over 16, we count them 1, 2, 3, 4, and it would just be negative 4. But it's got to be negative 4. Okay. Now these ones, write the expression as a single logarithm. Okay, you're condensing it. So my logs are both base 2s. They have to be the same base to condense it. And you take these multipliers, the 6 and the 3 are coefficients, and they come around, and that's an exponent to your product. Okay, so x to the 6, b to the 3rd. Now, you write log base 2. Then you make a parentheses, and you put your x to the 6th, and minus, if I'm condensing, means division. If that's a times, it'd be multiplication, but it's minus, so it's division, and it's b to the 3rd. That's it. Okay, expand into multiple logarithms. Now you're going the opposite way, and you're making it bigger. So the base is 2. Put a parentheses, and how many factors do we have? We have 8, that's 1 factor. X to the 3rd is 2 factors. Y to the 4th is 3 factors. So there's going to be 3 log base 2s. Okay, so you're going to put 8. You're going to put x to the third, but then you're going to ditch the 3 and bring it around here as a coefficient. Okay? And the same with the y to the fourth. The 4 is going to come around, that's a coefficient. Then you were dealing with multiplication, so when I'm expanding it, that goes into addition. Okay. Now for the equation solving. This is the most confusing part. I would say it's even more confusing than the story problems. Okay, equation solving. Know your operations. You got 3 to the power of 4x equals 243. So here's all the scenarios that could come up. The variable, which is x, variable's a power, variable's in a logarithm. Well, I don't see log anywhere, so no. Variable is to a power. Variable's just to the first power, and the variable's by itself. Well, our variable's a power here, okay? So I put x equals, and then I write that it's a power. First, parenthesize the base and the exponent. So the 3 and the 4x I'm going to put in a parentheses together. Undo outside operations. Well, we don't have any of them. Now, it's an or. That says or. You circle your exponent. If your base is a number, which 3 is, I would set the power 4x equal to the log over log, the COB. Now, if the base is e, you want to do something else, okay? But the base is a number, so we want to do the COB. So you set your power 4x equal to log over log. That's the most surefire way. Base 3 on bottom, the product 243 on top. So you go log 243 divided by log 3. It's going to be 5 because 3 to the 5th is 243. So I've got 4 times x equals 5, then I just solve for 4. If I solve for x by dividing by 4, so it's 1.25. Okay, 16. Again, you're solving for x, and the variable is the power, okay? So it's going to follow the same method. Parenthesize the base and the exponent. Undo operations outside, which we don't have any. And since my number's a base, my base is of numerical value, I will be applying the COB, the change of base formula. So I take that x minus 4 and I set it equal to log over log. Punch it into your calculator, right, and you're going to get 3, because 3 to the third is 27. That's why that's 3. Then you add 4, and x equals 7. Okay, next problem, number 17. 2 times log base 4 of x equals 8. Okay? Now, the variable is now in a logarithm. Okay? It's not a power, it's in a logarithm. Make sure there's only one log or ln. And there is. That's the only time I see log, so we're good. Parenthesize the log, base, and product, and undo any operations outside. So you're going to parenthesize the log, its base 4, and its product x. Because you have an operation outside. You have a times 2. Okay? So you need to get rid of that by dividing by 2. Is how I would deal with it. So now you have log base 4 of x equals 4. Now, rewrite into an exponent, which you can because you have an actual log. You don't have the ln. If you have ln, you got to take the e from each side, but we don't have ln. We have a log base 4. So if we have an actual log with a base, we want to rewrite that into an exponent. Remember how to do that. This is your base. This is your power. And this x here is your product. Okay, so 4 caret 4 equals x. So 4 to the 4th power is 256. And that is how you solve for x within a logarithm. Okay. Next problem. 4 times e to the 3x power equals 200. So you're solving for x. Okay. Again, the x variable, that's in the power. It's up there. You see it. It's a power. So you do what you've done before. Parenthesize the base and the exponent, the e and the 3x. Okay. Undo outside operations. We do have an outside operation of a times 4, so we need to divide by 4. And that's 50. Now circle your exponent. You're not going to be able to do COB because the base is e. So what you do if the base is e, you take the ln of each side. So you put ln, and that cancels your e, and you put ln over the 50. Because now we just have the expression 3x. And now on the other side, I find out what the heck the natural log of 50 is. You can't just put 50. You got to evaluate the natural log of 50. 3.91. Then I just divide by 3. 3.91 divided by 3, 1.30. Okay, now the variable again, ln x plus 5 plus ln x minus 5 equals 3. So the ln is a logarithm. It stands for the natural log. So again, the variable is in a logarithm. So you're going to be looking here. Make sure there's only one log or ln. See, right now there's 2, so we have to do the condensing to get it down to one logarithm. So I put ln with kind of a big parentheses, then equals 3. And after that ln, we put x plus 5, and then I see plus, so I will be multiplying it by the product in the second natural log, which is x minus 5. Okay. So now I've made sure there's only one. Now I parenthesize the log base product, undo any operations outside. There are no operations outside, so you're good there. Now you can't rewrite this into an exponent because you have ln. So what you do when you have ln is you take the e power from each side. So you put e, put a power, e, put a power. This cancels, and I need to simplify that inside. Okay. So I need to FOIL it. E and ln's gone, but I got to find out what x plus 5 times x minus 5 is. So I take x times x. I take x times negative 5. I take 5 times x. And I take 5 times negative 5. So that's x to the second, negative 5x, positive 5x, and negative 25. Now I know these cancel, they make 0. So on that side I just have x to the second power minus 25. Now on this side you got to figure out what e to the third is. So I go second ln e third. 20.09. Now I can solve for x, okay? Now my x variable is a power, okay? So decide if you have to factor or use linear properties followed by the radical, because you have x second, okay? So usually that's 2 answers, okay? But you have x second only, okay? It's not like you have an x second and then somewhere there's an x to the first or an x to the third. It's just x to the second only. So you're going to apply the linear properties. Linear properties is what I'm writing. And then you're going to follow that up by applying a radical 2 and figuring that out. Okay? So, plus 25. Plus 25, that's 45.09. Now, so that's what linear properties mean. Then you get rid of this 2 by applying our square root. Okay? 2 root. So 2 second caret 45.09, and that 2 root is even, so it could be the positive or the negative, okay? 6.71. So 6.71 or negative 6.71. Okay, now to the problem solving. A bank account contains $5,000. Its interest rate of 4% is 4% compounded quarterly. How much money will the account have after 3 years? Okay. Compound, okay. Compound interest is written this way. There's a go-to formula right away. You have P times 1 plus R divided by N to the power of N times T equals A, okay. Okay, so you got to know what your variables are. P R, N, T, and A. Now remember, P and A stand for the same thing. P is where your money started at, and A is the money that you ended with. Well, you know the money you started with is $5,000. You don't know the money you ended with, so we're going to believe that is A. Now we got to know R. R is your rate. Don't add it to 100 because the 1's right there. So you just take that 4% and move the decimal twice to the left. So 0.04 is your R. Okay, then the N. The N is 4. Okay. Because it cut quarterly. Quarterly means that N equals 4 because that's 4 times in a year. And the years, T is 3. So if you see quarterly, that's 4. So put the stuff into your equation. So P is 5,000. 1 plus. Then your R is 0.04 divided by your N, which is 4. And then N times T. So it's going to be 4 times 3 equals A. Now you need to simplify your exponent. 4 times 3 is 12. And you need to simplify your base. So 1 plus 0.04 divided by 4 is 1.01. So now we have 5,000 times 1.01 to the 12th power equals A. So we're solving for A. Now what kind of variable is that? A is not in the power. It's not a logarithm. It's not to any power that I see. Okay. It's by itself. It's to the first power, but it's also by itself. So if it's by itself, you simply evaluate the other side. Okay. You don't have to use any linear properties to solve it. Okay. You just plug the other side in. So 5,000 times 1.01 to the 12th power. $5,364.13. Okay, moving right along. Next one is not a compound interest, so I should not see that same formula used. As a town gets smaller, the population of its high school decreases by 6% per year. The senior class has 160 students now. In how many years will it have about 100 students? Okay, so years and students. Since it's not a compound interest, we want to write the equation the old-fashioned way. X is years, Y is students. X is your time. So students per year. There's no set amount of students per year. It's a percentage. It's proportional, so it's 6%. Okay, well, that makes this not a linear function or a quadratic function. It means it's an exponent function. It'll be decay because we'll end up minusing because it's going down. And you need to know what your factor is. Okay, to find your factor, you take 100%. And you're going to minus 6% because it's decreasing, so it's 94%. Now you need to write that as a decimal, 0.94. So we know how to write out exponent equations from word problems. A times B to the x power equals y. So we got to know what the A, the B, the x, and the y represent. Now A and y stand for the same thing, so y is students. Where the students end, and A is the students as well, and that's where they begin. So there's two quantities of students, so I know both of these because we have 160 now, so that's where they begin, and then 100, just they're in chronological orders where they ended. Now the B is your factor, 0.94, that is your B. The X is what we don't know because X is years, and that's what we're solving for. So that's going to remain X. So we have 160 times 0.94 to the X power equals 100. So where's my variable at? I have to solve for X, and the variable is a power. Okay, so we're solving for X, and X is a power. The variable is a power. So you parenthesize the base in the exponent. Undo outside operations. Oh yeah, we have to divide by the 160 before we do anything else. We divide each side by 160. 100 divided by 160 is going to be 0.625. Okay, then COB, or do I have to do LN? Well, my base is not E. E's not in this problem, so I'm doing the COB. So I circle my power, okay, and set the exponent, the power, equal to the log over the log. Okay, so 0.94 goes on the bottom, 0.625 goes on top. Then you plug that in and evaluate. So log 0.625 divided by log 0.94, I got 7.60. So that's my answer. Okay, now if you want to check that, you can take your original amount, 160, times your factor, 0.94, raise it to the power of 7.60, and it should be close to 100, which it is. Okay, an antique's value increases at a certain percent each year. Its value goes from $20 to $29.28 over a span of 4 years. What's the percent rate of growth? Okay, so again, you can't, it's not compounded, it's not interest, so you got to go years in money. Years is X, money is Y. So dollars per year. Well, there's no dollars per year, it's a percent. You don't know the percent, so you just put a percent sign, and that means it's an expo function again. And the factor, we just put that as B because we're unable to identify it. So we write our equation A times B to the X power equals Y. So A, B, X, and Y. Okay, remember A and Y stand for the same unit. Y is dollars, dollars you would end at, and A is the dollars you begin at. Well, we know both those. We have 20 for the beginning and $29.28 for the ending. So it's a growth, okay? Not that that really matters, okay? B stays B because we don't have that. That's kind of what we're going to have to solve for. And then X is a number of years, which we have is 4. So put what you know into the equation. So you have 20 times B to the 4th power equals 29.28. So I'm solving for B. The variable is not the power. The power is 4. There's no variable in the power, so we're not using that method. There's no logarithm. We're not using that. The variable is to the 4th power. So what you want to do, just put 4b equals right there. Okay, we're probably not going to be able to get 4 of them, but that's okay. Okay. Decide if we have to factor or use linear properties followed by a radical. Now we have b to the 4th, but that's the only type of b we have, so that's good. I can use linear properties. And then after that's done, I just use a radical 4 to figure out what b equals. So I don't need to factor. You do have to get rid of the divide by 20, the times 20. You have to divide by 20. That's what linear properties are. You got to get rid of operations around the b to the 4th power. So then we take 29.28 divided by 20, 1.464. Now you apply the radical. Okay. Now it's an even radical, so it will be a positive and a negative. So 4 second caret, 1.464, 1.10, okay? So positive 1.10, negative 1.10, and these cannot be found. Now you take your positive answer over here, but you need to do one really quick thing. You need to always subtract 1 whole from that. It's always 1, and then you move the decimal twice to the right to find the percent rate of growth. It would be 10%. Remember that. It's easy to forget. It's easy just to put the 1.10. You need to remember to minus 1 and move the decimal forward.